Hello all, in this presentation I try to answer all the questions of 2019 higher secondary chemistry examination. First question, what is the monomer of natural rubber? Monomer of natural rubber is isoprene, that is 2-methyl-1,3-butadiene. Second question, weakest reducing agent among the hydrides of 15th group elements. And we know that the reducing properties of hydrides of 15th group elements decreases while we going down the group because bond dissociation enthalpy decreases. So weakest reducing agent will be NH3. Question number 3. The reaction in which amides are converted into primary amine by the action of bromine and alkali is known as Hofmann's bromamide reaction. Question number 4. MnO4 minus and dash are formed by the disproportion of MnO4 2 minus in acidic moly. When MnO4 2 minus reacted with acid, it will produce MnO2 and MnO4 minus. When we come to question number 5, in a solution of components of A and B at molecular level, A and B, AB interactions are weaker than those between AA and BB interactions. That type of deviation, that is after mixing the solution, if the interaction will be lesser, that means there is bond breaking occur during the mixing of solution. So energy is it's an endothermic reaction. So that type of deviation is called positive deviation. Question number 6. Identify the coordination compound which can exhibit linkage isomerism. We know that having linkage isomerism is shown by the ligands, that is ambidentate ligands. The only one option which contain ambidentate ligand is option number C. Question number 7. For the reaction of 2NO plus O2 giving 2NO, the rate law is given is rate is equal to NO raised to 2. The order of the reaction with respect to O2 is 1. Write the chemical equation represent the Riemann-Tiemann reaction. As you all know, that is phenol react with the chloroform and alkali forms salicylaldehyde, hydroxybenzaldehyde. What is reverse osmosis? Write in two application. A process in which solvent passes through a porous membrane in the direction of opposite, that is from low concentration to high concentration, that is opposite of natural osmosis when subjected to a hydrostatic pressure greater than the osmotic pressure. There are so many examples. All the applications of reverse osmosis are related to desalination of seawater, deionization of industrial water. All are related to purification of water. Then identify the products and give the name of the following reaction. We know that aldehydes does not contain alpha hydrogen. Reaction with concentrated alkali, they are undergo self-oxidation and reduction and form sodium salt of acids and alcohol, and that reaction is called reaction. Question number 11. Explain the haloform reaction. Actually, this reaction is used for identifying aldehydes or ketones which containing CH3 group directly attached to the carbonyl group. So, aldehydes and ketone contain alpha hydrogen. On treatment with alkali, the alpha hydrogen, there must be 3 alpha hydrogen. That means there must be a CH3 group. On treatment with alkali, they will form haloform. If we are treating with iodine, they will form iodoform and yellow precipitate, and that is used as a test. What is step growth polymerization? Give an example. Step growth polymerization is actually an example of condensation polymer. It's a stepwise reaction between two functional or more than one functional group in which result in the formation of a high molecular weight polymer. Like very good examples of formation of nylon 6 from adipic acid and ethylene diamine. An element crystallizes in FCC manner. What is the length of the side of the unit cell if its atomic radius is 0.144 nanometer? So we know that for FCC, the relation between atomic radius and edge length is given as A is equal to 2 root 2 root 2 R. Say is equal to 2 into root 2 into R. R is 0.144 nanometer. So the final answer will be 0.407 nanometer. Draw the structure of He3PO2 and account for its reducing agent. In the structure of He3PO2, there are two pH hydrogen. We know that when phosphorus is directly attached to H, that bond is easily breakable and it is not ionizable. So they will act as a good reducing agent. Question number 15. 2-bromoprotein is optically active. Explain the stereochemical aspect of SN1 reaction of 2-bromobutane with OH minus ions. So it follows SN1 reaction. We know that during SN1 reaction, the first step is the formation of an alkyl carbocation. Then second step is the OH minus is attached to the carbocation. So for attacking OH minus, there are two options. It can come through the two direction. That means the resultant for compound will be a mixture of positive, that is positive and negative isomers, or dextro and levo isomers, and both will form in equal amount. As a result, the final product will be optically inactive due to racemization. Question number 16, briefly explain the two types of emulsion and give examples for each. There are two types of emulsions. So actually emulsions are liquid colloids. There are two types, oil dispersed in water and water dispersed in oil. The first one, the examples are milk and washing cream, and second one examples are butter and cream. Question number 7, give the structure formula and IUPAC name of the product formed by the reaction of propanol with CH3 MgBr in dry ether followed by the hydrolysis. So Grignard reagent, when treated with ketones, it will produce tertiary alcohols. So we'll get a 2-methyl 2-propanol by treating with propanol with CH3 MgBr. 18. Examine the graph given below. Identify the integrated rate equation and the order of the reaction corresponding to it. We know that the graph is drawn by following the equation y is equation for a straight line, that is y is equal to mx plus c. So y is r and m is the y-intercept, and y is equal to mx plus c. So here r is equal to minus 80 plus r0. Here minus k is the slope. So this is an equation for zero order reaction. Question number 19. How is primary amine distinguished from secondary amine using a chemical test? So for identifying the primary amine, the best test is carbylamine. That is, primary amine on treatment with chloroform and alkali will give a foul-smelling liquid of highly poisonous isocyanate. But the secondary amine do not react with this reagent. Question number 20. Predict the product obtained by the reaction of 2-methoxy 2-methyl propane with HI. So during this reaction, if there is a tertiary alkyl group, the halogen will always go to the tertiary alkyl group because tertiary alkyl carbocation is more stable. Explain the terms zeta potential, electrophoresis and electroosmosis. Zeta potential, the electrical potential difference between two ionic layers around a colloidal charged ion, or the electrical potential difference between interface of a double layer. Higher the value of zeta potential, more stable will be the colloid. Electrophoresis. Electrophoresis is a migration of colloidal particle under the influence of electric field. If the same electrophoresis is done by placing a parchment membrane, that is called electroosmosis. That is movement of a solution through a semi-permeable membrane under the influence of electric field. That is called electroosmosis. Then the question number 22, that is the problem. The rate constant of a reaction at 293 Kelvin is 1.7 into 10 raised to 5 second inverse. When the temperature is increased by 20 Kelvin, the rate constant is increased to 2.57 into 10 raised to 6 second inverse. Calculate the activation energy and Arrhenius constant for the reaction. In this reaction, we have to use the equation log K2 by K1 is equal to A divided by 2.303 R into T2 minus T1 divided by T1 T2. Using that value, first find out the activation energy and then substitute the value of activation energy in the second equation, that is K is equal to A into A is Arrhenius constant. Identify A, B and C in the following reaction. In this reaction, first step, acid react with ammonia and form an ammonium salt. On heating, it will produce an amide. So A is an amide. Then on hydrolysis, amide on complete hydrolysis, we know that it will produce carboxylic acid. So B is carboxylic acid. Then second step is the treatment of a carboxylic acid with bromine and red phosphorus. So here the carboxylic acid containing alpha hydrogen, so it will undergo HVS reaction, otherwise it will form acid chloride. In this condition, this is an acid with alpha hydrogen, so the final product will be tribromoethanoic acid. Question number 24, briefly explain the different type of neurologically active drugs and give examples for each. We know that the drugs which affect the central nervous system are called neurologically active drugs. There are two types, tranquilizers and analgesics. Actually, tranquilizers induce sedation by inducing or affecting the central nervous system, and analgesics, there are two types, narcotic and non-narcotic. And the examples for tranquilizers are Equanil. Then analgesic examples, aspirin, paracetamol, etc. Question number 25, write any three applications of D and F block elements. There are so many applications we can find out. We can write iron and its amalgam, steel, except that's alloys of iron utilized broadly in development industry. Then titanium used in the manufacture of airship, tungsten in electric fibers. Then in F block elements, lanthanide oxides are used in cleaning glass as abrasives. Thorium is used as a part of cancer treatment, and uranium is used in as a very good atomic fuel. Question number 26, the open structure and closed structure of glucose. Actually, I pull out this structure from Google. It's very difficult to draw. Then the proof of existence of anomers, because we know that glucose can be extracted in two different physical forms. That explains the anomery structure of glucose. Then the question number 27 is a problem. The 5% solution of by mass of cane sugar in water has a freezing point of 271 Kelvin. Calculate the freezing point by mass. 5% of glucose in water. Freezing point of pure water is given. So using the first thing, that is using molar mass of cane sugar and the given things, we have to find the Kf, because Kf is not given. So using delta Tf is equal to Kf into M. Then M is the molality. Using that, find out the Kf. Then substitute the value of Kf in the second condition and we can find the freezing point. First find delta Tf, then find the difference and we'll get the freezing point of glucose solution. Question number 28, explain the steps involved in the paper phase refining of nickel and zirconium. This is a method based on the principle that impurities are more soluble in the molten state of the metal than the solid state. We know that a circular heater is moved on the rod of the impure metal, and this process is repeating. As repeating, we'll get pure metal on one side and impurity on the Question number 29, that is interhalogen compounds. Interhalogen compounds are compounds formed between halogens. There are different types of digital formula X, Y, N, where N is equal to 1, 3, 5, 7, etc. The X will be more, S is the less electronegativity of the two halogens. Then the second part of that question is which interhalogen compound is used to fluorinate uranium and how it is prepared. We are using ClF3, trifluorochlorine, for using fluorinating uranium, and the equation is given. Then question number 30, how can the following conversions be effected? First one, ethanol to fluoroethane. So we know that we can convert all alcohols to bromo, chloro, iodoethane easily. But in the case of fluorine, it will not directly react with the fluorinating agent, will not easily directly react with alcohol. So in that case, first we'll convert into any of other halogens like bromine, iodine, or chlorine, etc. Then after that, we're using Finkelstein reaction, that is CH3CH2Br plus AgF gives CH3CH2F. Fuel cell. The diagram of fuel cell is given, and the half cell reaction at cathode oxygen reacts with the water in presence of the 4 electron. That is, first reaction is anode. Hydrogen will react with the OH minus from the electrolyte, gives 4 water and 4 electron. That electron will reaches the cathode compartment. O2 will undergo reduction and form 4 OH minus. As a result, the electrolyte concentration is always remains constant as long as the hydrogen and oxygen will passed into the fuel, it will continuously waltz. Then point defects and explain the non-stoichiometric defects in crystal. Point defects, when the deviation occurs around an atom or a particle at a particular point, that is called point defect. Then metal, there are non-stoichiometric defect. There are two types: metal excess defects and metal deficient defect. Metal excess defect, that is one of example when sodium alkali metal halide on treatment with metal vapor, its on metal vapor, it will loses its anion producing F centers, that is the excess electron which will trapped in the holes are called F centers. Due to the F center, the compound will be colored and conducting. Then in the same case, another example in the case of zinc oxide, that is extra cation. A zinc oxide on heating in presence of air, it will lose oxygen reversibly and create extra zinc ions in the metal lattice and 2 electron. As a result, it will also become colored and conducting. Then metal deficiency defect is normally shown by compounds of transition metals. For example, compounds of iron and nickel, copper, etc. A very good example is iron sulfide. One of the transition metals, some of the transition metals are completely missing from the lattice. To maintain the electrical neutrality, some other cations, that is Fe2 plus, will be converted into Fe3 plus. So as a result, it will produce extra electron. This extra electron will make this metals glow in when light falls on it. That is all, it glitters, because the difference between the sodium chloride color, that is yellow color, when it has a deficiency defect, and iron sulfide will glow like gold. So that's why it is called fool's gold, because it is glowing. There is a luster because the extra electron cannot be situated inside the crystal. It will placed only outside of the crystal. These are the two defects. Then with the help of a diagram, give the splitting of d orbitals of Mn2 plus ions in an octahedral field. Mn2 plus ion, the electronic configuration of Mn2 plus is equal to d5. Manganese, the electronic configuration is equal to D5, 4s2. After losing 2 electrons from 4s orbital, it has 5 electrons. That is splitted into 3 in octahedral splitting, 3 orbital with low energy and 2 orbital with high energy. Low energy orbitals, the 3 orbitals are called triply generated, and the other high energy orbitals are called, there are only 2, that is, it is called doubly generated. When it comes to the 2 compounds, hexahydro manganese, in that case, there are only difference in ligands. Both has the same oxidation state. In both the compounds, Mn is in +2 oxidation state. That means it has D5 electrons. But when we compare the ligands, water is a weak ligand and cyanide is a strong ligand. So weak ligand will split the orbital, that is Eg and T2G, in a very small distance. As a result, only 3 electron will go to T2G and other 2 electron go to Eg2. So all the electrons are unpaired because there are 3 orbitals in T2G. Each one will situated in each orbital. There are 3 unpaired and 2 electron in Eg, and each one in situated in each Eg orbital, and therefore there are total 5 unpaired electrons. But in the second compound, the cyanide is a strong ligand, so the splitting energy, that's the difference between T2G and Eg, will be very high. As a result, electrons have a tendency to go to the low energy orbital, so they will go to the T2G orbital. All the electron will go to T2G orbital. There are 3 orbitals, so 2 of them will be completely paired and 1 will be unpaired, so only 1 unpaired electron.